The air in the laboratory carries a distinct smell. It is a sterile chemical scent, a mix of formalin and ethanol. These are the preservatives used to fix and protect the precious tissues stored here. This is the Imperial College London Brain Bank, a quiet and ordered space dedicated to understanding the human brain. The constant low hum of refrigeration units fills the background, a reminder of the delicate biological specimens they hold. Stainless steel benches line the room, reflecting the cool, fluorescent lights above. On these benches lie the instruments of a very specific and very important scientific craft. It's a place that feels both clinical and sacred, a library where the books are not made of paper, but of human memory and experience. This unique environment is where the mysteries of neurological diseases are carefully unraveled. The atmosphere is one of intense focus and profound respect. Every container, every label, and every tool has a purpose. The sounds are subdued, the soft click of a metal instrument on a tray, the quiet whir of a ventilation hood, the rustle of a lab coat. It is a place built for concentration. The work done here requires a steady hand and an even steadier mind. The scientists who walk these halls understand the weight of their responsibility. They are the custodians of final gifts from individuals who chose to donate their brains to science, hoping to help future generations. The visual landscape of the lab is one of precision and order. Racks of labeled jars and containers are organized with meticulous care, each one holding a story waiting to be told. Microscopes stand ready on nearby tables, their lenses promising a glimpse into the cellular world of the brain. On the main bench, a specialized cutting station is prepared. It includes a large grooved board, long sharp knives, and trays for organizing the resulting slices. The scene might seem intimidating to an outsider, but to the neuropathologist, it is a familiar and necessary part of the journey toward discovery. It is here that the invisible damage caused by diseases like Alzheimer's and Parkinson's can finally be made visible. The feeling in the room is not one of morbidity, but of purpose. It is a place of hope, where tragedies are transformed into knowledge. The sterile smell, the humming machines, and the gleaming steel all serve a higher goal: to understand what goes wrong in the brain, and ultimately, to find ways to fix it. This laboratory is a bridge between the past and the future. It connects the lives of those who have passed with the potential for healing those who are still living. The work is a tribute to the donors and a commitment to solving some of the most challenging medical puzzles facing humanity today. At the center of this world is Professor Steve Gentleman, a neuropathologist with decades of experience. When he begins his work, his focus is absolute. He seems to enter a state of deep concentration, a concept the psychologist Mihaly Csikszentmihalyi called flow. In this state, a person is fully immersed in an activity, feeling energized and engaged. For Professor Gentleman, everything outside the task at hand seems to melt away. The hum of the freezers, the distant sounds of the hospital, they all fade into the background. His attention is entirely on the brain before him, a complex organ he has dedicated his life to understanding. His movements are deliberate and economical, honed by years of practice. There is no wasted motion. Each gesture, from picking up a knife to making an incision, is performed with a quiet confidence that comes only from deep expertise. He works methodically, following a precise protocol that ensures every sample is processed correctly. As he has said, "You get into a rhythm. You have to be systematic." This systematic approach is crucial. It guarantees that the data gathered from each brain is reliable and can be compared with others, building a larger picture of the disease process. His focus is not just on the physical task, but also on the story the brain can tell him. This state of flow allows him to perform a task that many would find difficult, if not impossible. The work requires him to disconnect emotionally from the more unsettling aspects of handling human tissue. He is not being callous. He is being a professional. This psychological state enables him to maintain the objectivity needed for scientific analysis. It is a necessary skill for anyone in his field. The deep immersion in the process transforms a potentially grim task into a focused intellectual pursuit. The goal is not just to slice the tissue, but to unlock the secrets held within its intricate structures, searching for the telltale signs of neurodegeneration. His intense focus is also a form of respect for the donor. By concentrating so completely on the task, he ensures that this final, generous gift is used to its fullest potential. There is no room for error. The information that can be gleaned from this one brain could contribute to a breakthrough that impacts millions of lives. Professor Gentleman's flow state is more than just a work habit. It is a vital part of the scientific process. It allows him to perform his duties with the precision of a surgeon and the intellectual curiosity of a detective, all in service of a greater good. The process of brain slicing begins with a whole human brain, preserved and firm to the touch from its time in formalin. Professor Gentleman places it carefully onto a specialized cutting board. The main tool for this process is a long, incredibly sharp knife, similar in appearance to one used for carving bread. The length is important. It allows him to make a clean, continuous cut through the entire hemisphere in one smooth motion. This prevents any jagged edges or tears in the delicate tissue, which could compromise the microscopic analysis later. The brain is first cut in half, separating the left and right hemispheres. From there, he begins slicing one hemisphere into thin, parallel sections, each about 1 centimeter thick. He works his way from the front of the brain, the frontal lobe, to the back, the occipital lobe. Each slice is a cross-section that reveals the internal architecture of the brain. As each slice is made, it is laid out in precise order on a tray. This allows him to see the progression of structures through the brain, kind of like flipping through the pages of a book. Key areas become visible, such as the hippocampus, which is crucial for memory, and the substantia nigra, the area affected in Parkinson's disease. The color and texture of the tissue give him the first clues about the health of the brain. After the initial slicing, smaller, more specific blocks of tissue are taken from key regions of interest. These smaller samples are destined for the microscope. They are processed further, embedded in blocks of wax to make them stable. Then, an instrument called a microtome is used to cut incredibly thin sections from the wax blocks. Sections so thin they are measured in microns, or thousandths of a millimeter. These translucent ribbons of tissue are then mounted on glass slides. Finally, they are stained with special dyes that highlight different cellular components, making the invisible signs of disease visible under a microscope. The purpose of all this careful slicing and staining is to search for the pathological hallmarks of disease. For Alzheimer's, Professor Gentleman looks for amyloid plaques and tau tangles, abnormal protein deposits that disrupt brain function. For Parkinson's, he searches for the loss of neurons in the substantia nigra and the presence of Lewy bodies. Each slice, each block, and each slide is a piece of a puzzle. By examining them, he can confirm a diagnosis, determine the severity of the disease, and contribute valuable data to research projects aimed at finding new treatments. The entire process is a meticulous journey from a whole organ to a single cell. For many, the idea of this work might seem squeamish. Handling a human brain, the very organ of thought and identity, can be a daunting concept. However, Professor Gentleman explains this feeling fades with experience and purpose. "You don't get squeamish," he has stated. "It becomes a routine. It's a job that needs doing." This practical perspective is essential. The focus shifts from the unsettling nature of the material to the importance of the work itself. He sees the brain not as a grim reminder of mortality, but as a source of vital information. It is a biological specimen that holds answers to pressing scientific questions. This professional detachment is what makes the science possible. This work is profoundly important because it provides the definitive diagnosis for many neurological conditions. While doctors can make a clinical diagnosis in a living patient, only a post-mortem examination of the brain tissue can confirm it with 100% certainty. This confirmation is invaluable for families, providing closure and a clear understanding of what their loved one went through. It also helps researchers verify that their clinical diagnostic tools are accurate. By comparing the clinical symptoms with the actual pathology in the brain, scientists can refine their methods for diagnosing diseases earlier and more precisely in living patients. More than just confirming diagnoses, this work fuels future research. The tissue samples collected and preserved in the brain bank are distributed to researchers around the world. These scientists are working on a wide range of projects, from understanding the basic biology of a disease to developing new drugs. Without these precious human brain samples, progress in understanding conditions like dementia, Parkinson's disease, and multiple sclerosis would be significantly slower. Each brain donation becomes a lasting legacy, contributing to countless studies for years to come. The work done by Professor Gentleman and his team is the foundation upon which future breakthroughs will be built. Ultimately, the job is shaped by a deep sense of purpose that transcends the day-to-day routine. The long years of experience have not diminished his respect for the donors, they have deepened it. He understands that he is in a position of unique trust, tasked with honoring the final wish of individuals who wanted to make a difference. This sense of mission transforms the lab from a mere workplace into a nexus of hope and discovery. The careful, methodical slicing of a brain is not the end of the story. It is the beginning of many new ones, stories of scientific progress, and one day, stories of a cure.